So what does it mean when I multiply a given complex number by another complex number? This is a question that we had dealt with earlier, right? Suppose we have two complex numbers p, which is given by the complex number z1, and q given by the complex number z2. So therefore, each of these can be written as its magnitude times e to the power of I into theta 1, where theta 1 is the argument of this complex number, theta 1. Similarly, z2 is given by magnitude of z2 times e to the power of I theta 2. So it's given by this theta 2. So therefore, if I am multiplying z1 with e to the power of I times theta, where theta is the difference between the two angles, what am I getting? I'm getting the complex number z2. How? Well, it's equal to magnitude of z1 to the e to the power of I theta 1 times e to the power of I theta is equal to z2. Now what is theta? Theta is the angle which is the difference between theta 2 and theta 1. So therefore I get magnitude of z1 into e to the power of I theta 1 plus theta, which is equal to theta 2, which is equal to z2. So magnitude stays the same, but we have still a new complex number because it has a new argument, which is theta 2. So this is the complex number z2, right? So therefore, multiplication by a complex number is essentially equal to rotation by the argument of that complex number. Okay, so this is what rotation means. This is what multiplication by a complex number means. All right, let's look at an example based on this. The complex numbers z1, z2, and z3 satisfying the equation z1 minus z3 by z2 minus z3 is equal to 1 minus I root 3 by 2 are the vertices of which type of triangle? Or is it a triangle of area 0, or isosceles triangle, equilateral triangle, or obtuse angle triangle? Okay, so what do we have here? Suppose we have the three vertices of the triangle like this. So this is z1, this is z2, this is z3. So this would be z1 minus z3, that is the side z1 minus z3, z2 minus z3. So this would be z2 minus z3. Okay, and so what do we have? z1 minus z3 divided by z2 minus z3. And suppose I take modulus of that. So modulus of z1 minus z3 by modulus of z2 minus z3. This is equal to modulus of 1 minus I root 3 divided by 2. And that we know is equal to 1. So this gives us z1 minus z3's modulus is equal to modulus of z2 minus z3. And so this gives us that the two adjacent sides of this triangle are equal. So therefore, at least this is an isosceles triangle, right? Moreover, I get z1 minus z3 is equal to 1 minus I root 3 by 2 times z2 minus z3. What is that equal to? E to the power of I pi by 3, right? Because 1 by 2 is cos pi by 3, I into root 3 by 2. So that's minus pi by 3. So therefore, we get this into z2 minus z3, which means that the angle between these two sides of this triangle is pi by 3. What's pi by 3? 60 degrees. which means that it's an isosceles triangle with the apex angle equal to 60 degrees. It means that the base angles will also be equal to 60 degrees or pi by 3. So all of the angles of this triangle are equal to pi by 3 and two of its sides are equal. What is the conclusion? Obviously that it's an equilateral triangle. So option C is the correct answer to this question.